Picture this. You're staring at a massive, just a gigantic spreadsheet filled with thousands of rows of building energy data.
Oh, I know that feeling.
Right. And a blinking digital dashboard on your second monitor is flashing this alert, telling you that overall energy use is up by, say, 15% this week.
Yeah.
But you have absolutely no idea why.
Yeah.
And more importantly, you have no idea what you're supposed to actually do about it.
Which is the worst part.
Exactly. If you have ever felt that sheer panic when the utility bill arrives and there's a massive penalty you can't explain, you are exactly who we're talking to today. Welcome to the Deep Dive.
Glad to be here.
Our mission today is to figure out how to take all of that raw, chaotic, building energy data and turn it into trusted, actionable decisions.
It's a surprisingly common nightmare, honestly. We are currently generating more data in our physical spaces than at any point in human history.
Oh, for sure.
But having mountains of data does not equate to having solutions. In fact, unmanaged data usually just creates more problems.
Which perfectly brings us to the core of what we are exploring today. We are looking at excerpts from the favorite framework for strategic smart energy management.
That's right.
And I think a lot of us fall into this trap, where we assume creating a smart building is just a hardware installation.
Oh, constantly.
We think if we slap a bunch of high-tech sensors on a wall, connect them to the local Wi-Fi, and put a glossy dashboard in the lobby, we are suddenly running this optimized smart operation.
Yeah, that is the ultimate illusion of modern facility management. Without a highly structured pathway to channel that information, all the data you were collecting from those expensive sensors is just noise.
Just a wall of numbers.
Exactly. It becomes overwhelming very quickly. The reality is that smart energy management has to be designed with a rigid, logical structure. And that is what the Favorite Insight framework provides.
It's a progression.
Yes. It moves through 6 distinct layers, taking an organization from layer 0 up to layer 5.
Okay, let's unpack this and start right at the foundation, which Favorite calls layer 0. I found this concept fascinating because when we talk about smart buildings, the instinct is to immediately jump to the tech.
Of course it is. Tech is exciting.
Right, but layer 0 is entirely about intent and context. It demands that you figure out your intent before you touch any technology.
And that restraint is vital. Before a company deploys a single piece of hardware, before a technician wires up a meter or a software engineer designs a glowing dashboard, the organization has to define the actual business problem they are trying to solve.
You have to know what you're looking for.
You have to ask a very basic question, like, why are we collecting this energy data in the first place?
Yeah.
Furthermore, what does normal consumption actually mean for your specific building?
Because normal is entirely relative.
Oh, absolutely.
Like a hospital running MRI machines and life support 24 hours a day has a completely different baseline for normal than, say, a suburban retail space or a corporate office building that sits empty on Sundays.
That is a critical distinction to make. At layer 0, you also have to define the specific risks that keep your executive team awake at night.
The real pain points.
Right. Are you primarily terrified of peak demand penalties destroying your quarterly budget? Is your main concern carbon exposure and meeting environmental regulations?
Or maybe you're running a manufacturing facility where equipment failure and operational downtime are your biggest threats.
Exactly. You have to know what actions you will take when an anomaly is finally detected. If you don't have a plan for how to use the answer, there is simply no point in asking the system the question.
So it's essentially setting the rules of the game before the game even begins.
That's a great way to put it.
Some of the most common intents a building might have include reducing avoidable electricity waste or trying to control those massive peak demand charges. For others, the goal might be improving HVAC performance, supporting their ESG and carbon reporting, or just strengthening overall corporate governance.
Yeah.
The major takeaway for you listening is that layer 0 sets meaning before the data even exists. It's entirely outcome-driven.
And once you have that intent locked in, once the whole team knows why this project exists, you can step into layer 1. This is the data foundation. If layer 0 is the philosophy, layer 1 is where you capture physical reality.
Capturing reality means getting down to the actual hardware, right?
Yeah.
We need the physical layer to start feeding us information.
Yes, your energy systems must stream reliable telemetry.
And for anyone not living in the engineering world every day, telemetry is just the automated process of collecting data at remote physical points and transmitting it back to a central system for monitoring.
Spot on. We are talking about streams of data coming from your main power meters, of course, but also from sub-meters that might be isolating data by specific floors or by individual tenants in a commercial space.
So it goes much deeper than just the main power lines.
Oh, much deeper.
We're talking about the HVAC systems keeping the building cool, the heavy chillers, the complex lighting circuits. It includes the elevators.
Yep. Elevators use a ton of power.
And if you have a solar generation system up on the roof, you need telemetry from those panels to know what you're producing. It even extends to the water and gas meters.
All of those physical endpoints are capturing the heartbeat of the building's daily operations. Technically speaking, this layer uses standard IoT or Internet of Things protocols.
Right.
These are the standardized languages that devices use to talk to each other, allowing them to transmit all of this information securely into Favorite's time series storage.
Let's break down that term, time series storage, because it sounds highly technical, but it's actually a very intuitive concept.
It really is.
Instead of just taking a single snapshot of your data, time series storage records every single data point alongside the exact time it happened. It's like a flip book of your building's energy use, frame by frame, rather than just one static picture.
That is a perfect way to visualize it. Energy management is fundamentally about understanding how consumption changes over time. You need to know not just that power spiked, but that it spiked at exactly 2:14 p.m. on a Tuesday.
The exact moment.
Right. This Layer 1 foundation guarantees three things: continuous data flow, highly secure storage, and scalable ingestion. Whether you are managing a single boutique office or a massive portfolio of skyscrapers across different time zones, the data has to flow flawlessly.
Because the data is bad.
The absolute golden rule here is that without trusted data, trusted insights cannot exist.
If the data is bad, everything built on top of it is just a very expensive hallucination.
Exactly.
So, assuming we have a rock-solid Layer 1, we move up to Layer 2, which is descriptive insights. The core question we are trying to answer here is simply, what is happening? This is the moment the building finally gains visibility.
This is usually the stage where facility managers get their first big aha moment. They log into the system and they can suddenly see real-time total consumption.
They can see it all laid out.
Yeah. They can pull up historical energy trends over the last 6 months. They can look at load distribution to see which specific zones or floors are pulling the most power. They can calculate their energy intensity per square meter, or see exactly how much renewable solar energy they are generating compared to what they are pulling from the grid.
It sounds incredibly powerful.
Yeah.
But there is a catch here, isn't there?
There is a massive catch. What's fascinating here is that while Layer 2 provides incredible situational awareness, it is ultimately just visibility without interpretation. Facility managers can see a red line spiking on a chart, but they don't understand the underlying causes of that spike. They have the what, but they're completely blind to the why.
Right.
It is like looking at a car's dashboard and seeing the check engine light come on. You know something is wrong, but the light itself doesn't tell you how to fix the engine.
And nobody wants to just stare at a dashboard feeling helpless. We want to know why the engine is acting up, which naturally pushes us into Layer 3, Diagnostics Insights. Here's where it gets really interesting. The question shifts from what is happening to why did it happen? Because energy anomalies in a building don't just occur by magic. There is always a physical reason.
Always. Layer 3 is where the framework transitions from merely observing symptoms to actively diagnosing causes. The system achieves this diagnostic power through a few key methods, the most important being cross-sensor correlation.
Cross-sensor correlation.
Yes, this is where the true value of a smart system becomes apparent. It takes data from completely different types of sensors and layers them together to find the truth.
Give us an example of how that cross-sensor correlation actually plays out in a normal building.
Let's say you have a conference room. The power meter shows a massive spike in energy usage for that room.
Okay.
On its own, that is just a symptom. But if the system correlates that power data with the room's temperature sensor, and then correlates that with the occupancy sensor, a clear picture emerges. If the power usage is huge, the temperature is dropping rapidly. But the occupancy sensor shows the room has been completely empty for 3 hours.
You don't just have an energy spike. You have an HVAC system that is running at full blast in an empty room.
Precisely. That context changes everything. You go from we're using too much power to someone left the AC running in the empty boardroom.
It's so much more actionable.
It is. The system is also constantly comparing current behavior against the established baselines we talked about in layer 0. It uses pattern recognition across similar time periods to give you early anomaly understanding.
Thinking about how Favory diagnoses these issues brings up some really relatable workplace scenarios. For instance, if you were seeing strange nighttime energy spikes, Layer 3 diagnostics might correlate that with an HVAC override setting.
Exactly. Maybe a cleaning crew came in at 9 p.m., bumped the thermostat down, and forgot to reset it.
Right. Another crucial example to highlight is a sudden load increase on a piece of machinery. The system often recognizes that as equipment degradation.
Yes, which is huge.
It means a motor in the basement is suddenly working twice as hard just to produce the same output, usually because a belt is wearing out or a filter is clogged.
And perhaps the most revealing diagnostic is unusual weekend consumption. If a commercial building is completely closed on a Sunday, yet the system is diagnosing a massive, steady pull of electricity, you're looking at operational leakage.
Just burning money.
Basically. Systems that should be sleeping are staying wide awake. It is a shift from passive observation to an active, deep understanding of the building's physical state.
But the framework doesn't just stop at understanding the present or analyzing the past. It actually moves into fortune-telling.
It does.
This brings us to layer 4, predictive insights. So imagine if your building could learn from past energy behavior to forecast future demand. The question now becomes, what may happen next?
Leveraging all of that historical time series data we securely stored back in layer 1, the system begins to estimate peak load risks before they materialize. It identifies seasonal trends and generates early warnings.
It's looking ahead.
Yes. It looks at the weather forecast, compares it to how the building reacted to similar weather 3 years ago, and predicts exactly how much power the chillers are going to need tomorrow afternoon.
So if you are the person listening to this who manages the facility budget, what is the so what here? How does predicting the future actually save you money or time?
The financial implications are massive, primarily through demand charge optimization.
Right.
To explain that simply, utility companies don't just charge commercial buildings for the total amount of electricity they use. They also charge a premium based on the highest point of consumption during the billing cycle, the peak demand.
It's essentially the utility company's version of surge pricing.
Exactly. If your building spikes its power usage for just 15 minutes on a hot Tuesday afternoon, you could pay a massive financial penalty for the entire month. Layer 4 predicts when that spike is likely to happen, allowing you to prepare.
It also directly supports preventive maintenance scheduling, doesn't it?
It does.
Mm-hmm.
Instead of waiting for a chiller to violently break down on the hottest day of July, causing a crisis and an expensive emergency repair, the predictive layer warns you in May that the data trends indicate a high risk of failure.
Wow.
You schedule the maintenance on your own terms. The building begins to think ahead rather than just reacting late to an expensive crisis. It's serious risk reduction in high-load scenarios.
We are moving from a reactive state to a proactive state.
Oh.
But even knowing the future isn't the final step. We still have to take the wheel and do something about it.
We do.
That brings us to the absolute peak of the framework. Layer 5, prescriptive insights. We have predicted the future, but the question now is, what should be done? Insight is finally turned into action.
At this prescriptive stage, alerts are evaluated by configurable rules, recommending the right intervention at exactly the right time. But a crucial detail here is that it maintains human oversight and control.
It's not just taking over.
Right. It isn't a rogue AI making wild changes to your building's infrastructure on its own. It acts as an incredibly smart decision support co-pilot.
So what does a Layer 5 intervention actually look like in practice?
Well, it might mean the system automatically triggers a high-priority alert when consumption is about to exceed your defined peak threshold.
Okay.
It might actively recommend a load-shifting strategy, meaning it advises you to pre-cool the building early in the morning when electricity is cheap, so you can turn the AC down during the afternoon peak tariff periods.
That is so smart.
It prescribes specific maintenance checks because it noticed that slow decline in energy efficiency. And it can even be set up to automatically escalate ESG performance deviations directly to the management team.
That escalation capability means the data has fully completed its journey. And intent at Layer 0 has traveled all the way through the system and resulted in an optimized physical action at Layer 5.
Exactly.
Let's take a breath here and pull back to look at the whole picture. For you listening right now, whether you are managing a single facility, overseeing a massive corporate operations budget, or directing a company's sustainability program, why should you care about adhering to this rigid six-layer framework? Why can't we just wing it?
If we connect this to the bigger picture, you can't wing it because energy management impacts the core survival of an organization across 4 major strategic fronts.
Let's hear them.
The first is financial discipline. For decades, companies viewed energy costs as a fixed reality, like paying taxes, you just paid the bill, whatever it was. But energy is actually a controllable operational expense.
Right.
Structured monitoring eliminates invisible waste and dramatically improves your demand management. You literally stop throwing money out the window.
The second front is operational reliability. We touched on this when discussing the diagnostics of a struggling motor. Energy anomalies are very rarely just electrical issues. They're almost always early warning signs of mechanical stress.
Yes.
Catching those signs early protects your physical assets and dramatically improves your building's uptime. You aren't just saving electricity, you are saving the incredibly expensive machinery that keeps the building alive.
Exactly. And the third front is one that dominates corporate boardrooms today, which is ESG and sustainability. This is massive.
Oh yeah, you can't ignore it.
This framework turns chaotic energy data into structured, undeniable evidence. When a company needs to calculate its carbon footprint, they have to track different types of emissions. Scope 1 emissions are the direct emissions from sources you own, like the natural gas you burn in your building's boiler.
Right.
Scope 2 emissions are indirect, like the emissions created by the power plant that generates the electricity you buy from the grid.
And when it comes time to report on those Scope 1 and Scope 2 emissions for a green building certification or to feed a high-level executive board dashboard, you can't just offer rough estimates anymore.
No, you definitely cannot.
Because you follow the layers, starting with clear intent and securing an uncorrupted data foundation, you have reliable, time-stamped, highly accurate data. That guarantees transparency. It means you are fully audit-ready. You have the actual receipts to prove your sustainability claims.
Which perfectly sets up the fourth front, governance. When energy performance is transformed from a guessing game into something that is measurable, comparable, and reviewable over time, it vastly improves the entire organization's compliance posture.
So the strategic impact of adopting the Favorite Insight framework is profound. A building stops being a passive piece of infrastructure. It becomes a highly measurable, continuously optimizable system.
It shifts from a chaotic culture of reactive troubleshooting, where facility managers are just running around putting out fires all day, to a state of disciplined operational intelligence.
To quickly recap the key use cases, this powers peak demand optimization, so you avoid utility penalties. It completely revolutionizes how you monitor HVAC efficiency. It gives you exact tracking on your renewable energy usage. It allows for flawless tenant sub-meter billing, and it completely streamlines executive sustainability dashboards.
But none of those incredible outcomes are possible without the sequence. You cannot leapfrog straight to a brilliant executive dashboard without first defining your intent at layer 0 and building a secure data foundation at layer 1.
So to summarize the journey for you today, it goes intent to data, to describe, to diagnose, to predict, to prescribe.
That's the framework.
And the final message from our source material is a very clear call to action. Organizations looking to strengthen cost control, boost their sustainability performance, and truly solidify their ESG credibility should contact Favorite. It's time to move confidently from intent all the way to action.
It really is the only way forward.
Before we go, I want to leave you with a final thought to mull over. Think about the building you are sitting in right now. As layer 4, the predictive layer, and layer 5, the prescriptive layer, become more advanced and deeply automated over time, at what point does a physical building stop being just a smart structure managed by humans?
That is a fascinating question.
Right. At what point does it start acting like an autonomous, living organism, independently negotiating its own energy needs and survival with the local power grid based entirely on those initial intents we set at layer 0? It's a wild thing to consider. Thank you so much for joining us on this deep dive. Keep questioning, keep exploring the spaces around you, and we will catch you next time.